Hello students. So till now we have studied about electric potential and electric potential energy. Today we'll be deriving a formula for electric potential due to a point charge. So first of all, consider a point charge at suppose O, and then consider a point A which is at a distance r from O. Now the electric potential due to this charge at point A we have to find. So as we have studied that electric potential at a particular point is the amount of work done per unit charge to bring a charge from infinity to that point. So we have to find the electric potential at point A. So it will be the amount of work done per unit positive charge which is displaced from infinity to point A. Now let M be some intermediate point and the distance from of M from O, let it be equal to x. Now the force on the unit positive charge at M, the force here will be 1 upon 4 pi epsilon naught q by x square. Now the formula for force is 1 upon 4 pi epsilon naught q1 q2 by r square. Here r is x, q1 is q and q2 is 1 because we are considering unit positive charge. Now if we consider that this charge at point M is displaced by a small distance dx, displaced to n by a small distance dx. So for that the work done will be the force into displacement. So this is the force and the displacement which we have considered, which is mn is equal to dx. So this work done is force into displacement. Now this negative sign here means that the displacement is opposite to the direction of the force. Now this was the work done in the case when we are considering a small displacement. Now if you have to consider the displacement of that unit positive charge from infinity to point A, so you have to integrate this formula from infinity to point A. So for that the total work done will be the integration of this small work done. So integration of minus f dx from infinity to r. So we have seen the formula for the force, that is 1 upon 4 pi epsilon naught q by x square. So here again the negative sign means that the displacement and force direction is opposite. So these quantities 1 upon 4 pi epsilon naught and q, these are constant. So we will integrate 1 upon x square with respect to dx. So the work done is you will get integration of x square, integration of x raised to minus 2 dx from infinity to r. Infinity and r are upper limits and lower limits. So as you know that integration of x raised to minus 2 is minus 1 by x. So we can write minus 1 by x here, and substituting the limits, that is infinity and r, substituting the limits, you will get this equation. So it is upper limit minus lower limit. So as all of you know that 1 upon infinity is equal to 0. So this term goes out and you have 1 upon 4 pi epsilon naught q by r. Now as we have defined that the potential is this work done. So you can write this as potential 1 upon 4 pi epsilon naught q by r. So basically this is the electrostatic potential at point A. Now if you consider this r infinity, then the potential becomes 0 because 1 upon infinity is 0. So you can say that at infinity the potential is 0. So the electric field which the formula for electric field which we had seen earlier, it shows that E is inversely proportional to r square, and the formula which we have seen now for electric potential, V is inversely proportional to r. So if you plot these two against r, taking r on x-axis, that is distance, and electric field and electric potential on the y-axis, you get these two graphs. This is for the electric field and this is for electric potential. So basically this is a small derivation, very easy derivation, and along with that it is very important also. So in the next lecture we'll be seeing the other derivation for the potential. Thank you.